Welcome once again to my channel. In today's video, I'm going to talk about polynomials and rational functions. So, what are polynomial functions? In general, polynomial functions are of the form p of x is equal to a n x n to the power plus a n minus 1 x raised to the power n minus 1, and it keeps going. a1x plus a0, where an is not equal to 0. So that's a general form of polynomial function. So we call this the nth degree polynomial. It's an nth degree polynomial. Right, n degree polynomial function, or a polynomial of degree n. Okay. Now the numbers an minus 1, the a1 and a0 are called coefficients of the function. N is a non-negative integer, and a is a real number. All right, so basically coefficients are the numbers in front of the variables. So we are saying that the n is a non-negative integer. In other words, the exponent cannot be negative number. It can also not be a fraction, because fractions are not integers. Integers are whole numbers, and they are opposites. That's what we call integers. And then the a, as I said, is a constant, which has to be a real number. So let's look at some examples of polynomials. So let's take something like 2x cubed plus 3x squared plus 4x plus 1. As you can see here, the coefficient of x cubed is 2. Coefficient of f squared here is 3. X is 4, right? And 1 is a constant. So you can see this 1, which represents the a0 is a constant. It's a real number. Now the exponents, if you look at exponents, and then we have invisible one over here, which usually we don't write. These are all integers. These are all integers. Okay? They are not fractions, and they are not negative. Another example will be x squared plus 3x plus 3. This is also a polynomial, right? So because of the square term, this is a special case of polynomial, which we call the quadratic function. Or we can say quadratic expression. Okay. Now this first one, which has a cube, is also a special case of polynomial, and that will be referred to as a cubic function or cubic expression. So non-examples will be like this. If I have 2x, say negative 3, plus maybe 3x to the power 2 plus 5. Because you have this negative exponent here, this is not a polynomial function. Another one which is not a polynomial function would be something like this. X to the power 1/2 plus 3x negative 1 plus 2. It's also not a polynomial function because you have a negative exponent over here, and also have a fraction over there as the exponent. So these are not polynomial functions. Now let's talk about something known as the degree of a polynomial. So what is a degree? Now the degree of a polynomial is simply the highest exponent of that polynomial, right? The highest exponent. That's what we call the degree. So let's look at some examples. If I give you the function f of x is equal to 2x squared, or let's make this cube, 2x cubed plus 3x squared plus 2x minus 1. And I ask you, what is the degree of this? If you look at the exponent, you have 3 over here, you have 2 there, and the invisible 1 here, and then nothing here, the constant, right? Now, the highest exponent in this function is 3. So this is going to be a third degree polynomial. Or a polynomial with a degree of 3. let's try another example. So let's create a little table here. And then I'm going to put a polynomial function here. And then we'll state the degree. So let's look at first one. If I give you f of x is equal to 3, we have a constant. What will be the degree of that constant? If you have a constant term, the degree of that constant term is 0. 0. Now, what about if I give you f of x equal to 0? What is the degree? If your function is equal to 0, there's no degree. Okay. There's no degree when it's equal to 0. Now, let's go back to the first one to explain why f of x equal to 3 has a degree of 0. Okay, so if I have f of x equal to 3, remember from the rules of exponents, I can write this as 3 times x raised to the power 0. Okay. What is any number raised to the power 0? Any number raised to the power 0 is always equal to 1. So basically, what we have here is 3 times 1, and that gives me the 3, right? So f of x equal to 3. That's where this comes from. In other words, the exponent for the variable which is missing was 0. So the degree is 0. That's the reason. But 0 is will not have any degree. All right, let's add one more here. F of x is equal to 4x to the power 5 minus 6x to the power 6 plus 3. What's going to be the degree here? Now, if I look through this function, the highest exponent of this function is 6. So that means that the degree of this will be 6. So that's a 6th degree polynomial. Okay. So that's how you determine the degree of a polynomial. Now, we also want to talk about the leading term. So what is the leading term? Now, the leading term is always the term that determines the degree of the polynomial, right? The term that has a degree of that polynomial. So let's look at an example here. If we have f of x is equal to 4x to the power 5 plus 3x to the power 4 plus 4x squared plus 1. And we want to determine the leading term. First, we need to determine the degree of the polynomial. The degree of the polynomial here is going to be 5. So it's a 5th degree polynomial. But 5 is the highest exponent of this function. Now, so what is the term that determines the degree? Now, this is the term. So that's where the degree is. It bears the degree. So this is going to be the leading term. This is the leading term. All right, so the leading term is 4x to the power 5. That is the leading term. Okay. And based on this, we can determine what we call the leading coefficient. So the leading coefficient is going to be the number in front of the variable that bears the degree or determines the degree, right? So if we take this leading term here, the leading coefficient is going to be this number here, which is 4, right? So our leading coefficient here will be equal to 4. All right, so that's how you determine the leading term and leading coefficients. This will become useful when you start working on division of polynomials. It's going to become very handy. Okay, so I'll create a video on dividing polynomials, and I'll mention this again, where we need to arrange the polynomial in what we call the standard form. So I want us to look at another example of how to find the degree of a polynomial. This time we're going to have more than one variable in it. Okay, so let's look at this example. So given that f of x is equal to let's just name a function. Let's call a function y. So y is equal to 5x squared y plus 2x 3y squared plus 2x squared plus 5. And you're asked to determine the degree. So what is the degree? Now, this is what you do. First of all, you determine the degree of each term. So you're going to take each term and determine the degree. So let's begin with this one here. So that's this is a term. So if I take this, how do I find the degree? In this case, you add the exponents. You're going to add up the exponents. So if I take the first one, the degree of 5x squared plus y. Remember, we have invisible one here. So the degree, you add up the exponents. So it's 2 plus 1. And then that is going to give us 3. So this is going to be a third degree. So this term is a third degree term. Now the degree of the next term here, 2x to the power 3y squared, you add up the exponents here. So you have 3 plus 2. So that gives us a fifth degree term. Then when we take the next one, the degree of 2x squared. Okay, this one has just a single exponent here. So the degree here is just going to be 2. So that is a second degree term. And then the 5, which is a constant, as we've seen previously, this is going to have a degree of 0. So that's a 0 degree. Okay. So what is the degree of the entire polynomial? after you determine the degree of each term. Now, the degree of the entire polynomial here is going to be the highest one, the highest degree, right? So if I look at all the degrees for each term, the highest one comes from this term here. So this is going to be a 5th degree polynomial. So the answer here would be, it is a 5th degree polynomial. Or you can just say a polynomial with a degree of 5. Degree of 5. Okay, right. So when they ask you what is the leading term, what is the leading term here? So the leading term in this case is going to be the term that determines the degree. So which term determines the degree? That's the one that I've just highlighted here. Okay, the degree came from this term. So the leading term is 2x cubed y squared. Okay, that will be your leading term. Okay. Now, what will be the leading coefficients? The leading coefficient is going to be the number associated with in front of the leading term, or the coefficient, is it right? The number in front of those variables, which is 2 in this case. Okay, it's going to be this number here. So the leading coefficient is 2. Okay. So this is how you determine the leading coefficient, leading term, and so on. So in my next video, we're going to look at how to find the zeros of a polynomial. And remember that you can perform so many operations on polynomial. You can do addition, you can do subtraction, you can do multiplication, and then you can do division. We'll look at all these examples in other videos. I hope I've made your life a lot easy in understanding how to find the degree, leading term of different kinds of polynomials. See you in my next video. Bye.